I'm going to start off today by disclaiming that I am not a medical doctor, and if you have medical questions, you should probably consult your doctor. Just getting that out of the way. I'm gonna tell you a quick story. It's going to pretty boil down how a certain form of observability it came pretty close to both saving my life and preserving my quality of life. Maybe a bit of both. So check out me back when I had not gray hair and in the hospital. I woke up one day at work. I just kind of woke up on the ground surrounded by paramedics. I had gone into a tonic-clonic seizure. Convulsions, I was covered in just about everything that you could expect your body to want to get rid of while you're having a seizure. All of your muscles are going on at the same time. It was pretty traumatic. And so where you see me here, that is a long-stay EEG, electroencephalogram, where they monitor your brain activity. What you see under that hood there is a series of electrodes that monitor your brain waves. And so I was in the hospital for about a week where they slowly deprived me of my anti-epileptic medication in hopes of inducing a seizure so that they could record which piece of my brain was malfunctioning in terms of electricity. And until this point, I was having seizures all the time. A lot of my teeth are just caps from having teeth broken from seizing and convulsing. Anyway, I'll spare you too much of that. But anyways, it took until this long stay EEG where they were finally able to figure out through inducing a seizure and recording it that it was my left temporal lobe that was misfiring. They could not find a tumor or anything like that. 7 out of 10 cases of epilepsy never really have a root cause discovered. I was very fortunate. I was a brain surgery candidate until they were able to track down where it was that was breaking, and were able to use medications and whatnot that were effective in these kinds of seizures. So yes, that's me, a little exposed. I'm sure you don't want me exposing myself any more than that, so we will move on. I'm here today to tell everyone observability on your bodies is not that different from observability on a service mesh for computers. There are a lot of biosensors available on the market today, both open and proprietary, that are certified for research and personal purposes. OpenSearch can handle the load of those metrics coming in and all of the unstructured data that might come with it. And there's nothing stopping anyone from using OpenSearch for both research and practical observability. Everyone with me still? Was that, how'd I do? All right, awesome. So we've heard the theory of observability quite a few times. You tend to hear it a lot at conferences like this. What does it refer to? What does it actually mean? Well, it's not just a tech buzzword. When we talk about observability, we're talking about the ability to infer the internal state of a system by monitoring its external outputs. So in this case, in my particular case, my external outputs were electricity and voltage coming through the skin on those electrodes you saw on my head there. That was an external symptom or an external output of some kind that they were able to observe, which led to knowledge being gained and the internal state of my brain being understood a little bit better. So this, I'm sure you can see how this applies to what we called observability in today's computer world as we've moved away from monolithic architectures and moved to service meshes. We usually use the word observability to refer to that. But today, I'm going to talk about bioobservability a little bit, which pretty much is what you're probably thinking. We're using the principle of observability on the human body. And it doesn't just mean the human body. I'll talk about that a little brief later. But I'm gonna probe you guys, just so you won't feel a thing, I promise. How many of you are wearing a smartwatch that tracks your heart rate? What about step counters? O2 sensors? Awesome. You are all practitioners of observability, of bioobservability. So like I said, we refer to observing external outputs on distributed systems. What kinds of forms do those usually take? Well, we usually talk about logs, we usually talk about metrics, we talk about traces, we talk about time series data, things like that. So those usually give us a good hint as to why something is wrong as opposed to something is just wrong. So those things, keep those in your head for just a second. The last time you went to a doctor and you had some problem that you described to your doctor, there's usually a handful of questions that they usually ask, and we're going to make just a couple of comparisons here. Has your doctor ever asked you, oh, well, when did this start? What are your symptoms? Does this run in your family? Things like that. Now, those are logs. There's no different. You've got no difference. You've got keywords in there that describe what's going on. When they ask you about a timeline, they're talking about time series data. And then when they move on from those questions, they go right to taking your vital stats. They check your blood pressure, they check your O2 saturation, things like that. Now, those are also metrics, the same things that we look for in observability of a computer system. Sometimes, doctors even are able to take traces from your body. Suppose they take a blood sample and they look for some kind of biomarker that indicates a problem with your body. Those are signals being sent between the parts of your body that have information about how it's behaving, and you can almost certainly identify or infer the internal state of your body by the kinds of things that they take traces of, the blood, urine, et cetera, et cetera. So that's the first comparison that I'd like to make, that when we're observing a service mesh or a very complex distributed system, we ask the same kinds of questions that doctors do when we're talking about our body. So that's the first comparison that I will make for you. And it makes sense, right? They want to know a timeline, they want to know the keywords, they want to know how things are moving throughout your body. That's tracing. That's logs, metrics, and traces. So I know what you're probably thinking, Nate. This is OpenSearch You're supposed to talk about OpenSearch. Bear with me for a minute. You're very right. Let me reinforce my narrative here a little bit before I move forward. Your body is a distributed service mesh. It's just a very complicated one that we have yet to figure out all the way. Consequently, it's very hard to infer the internal state of our body. Sometimes it's from lack of metrics, lack of traces, lack of logs, or lack of access to healthcare. Well, that's another subject. I would propose to everyone in here that the kinds of signals that are generated using our current means of healthcare are really no different than the kinds of signals that we ingest into OpenSearch. So here's another comparison for you guys. When doctor takes your pulse, what they're looking for is a number. They're looking for beats per minute. That's a metric. So we can ingest those into OpenSearch just fine. Those are the people have been doing that kind of metric ingestion for a long time. When they ask for things like when did it start, how long has it been going on, that's time series data. When they ask for the story, they're also asking for a time series data and other things to correlate. So we generate, through our visits with doctors, metrics, logs, and traces. So these are things that OpenSearch has proven to be excellent at handling, and that is the goal of today, is to share this correlation. And if you will humor me a little bit more, I'm going to share a few observations. It's what I just said. It's all just logs, metrics, and traces. OpenSearch eats these kinds of things for breakfast. It's really what observability is. And so we can ingest, store, and search through lots of this data. Many biological processes and experiments generate this same type of data. And that's not to say that it's just for real-time observation. You go into the doctor, they ask a bunch of questions. These are also relevant to medical research and experimentation. Instead of gathering real-time metrics on a person that comes into the doctor, there are plenty of data sets, albeit many of them private, that you could use, and OpenSearch would be a great tool to take these data sets, ingest them, analyze them, and create flashy visualizations that help you correlate between some of your body's external outputs and the internal state of your body. In my case, it was whichever part of my brain, my left temporal lobe, was misfiring electrically. So how does OpenSearch really facilitate this process? Ooh, I've got a clicker. So like I said, the patient's story, vital signs, blood pressure, O2 saturation, blood and urine time series for EEG. So all these things are textbook descriptors of the use cases of OpenSearch. So for instance, data ingestion and storage. OpenSearch can ingest, secure, store large volumes of structured and unstructured data, which are the same nature as the metrics that doctors and tests get from your body. Real-time search and analytics are also another feature of OpenSearch that researchers would find it very easy to make use of to find information quickly within massive data sets. It's an essential kind of thing for identifying patterns and trends across different biological indicators. Visualization and dashboards are another core feature of OpenSearch that support bioobservability. Allows people to create visualizations, operational panels. I'm sure many of you on your smartwatches and your step counters have, your portal where you look at how many steps you got that day. Those are all things. Now, another interesting way that it gets supported by OpenSearch is anomaly detection. In my case, this is what made bioobservability so very interesting to me, because when your brain starts firing random electrical signals, things tend to go pretty haywire. So I was very grateful to have an anomaly detected in my brain. And so any of these anomalies can happen in all kinds of medical data, and they always very closely infer some kind of problem that's going on inside your body. So vector database capabilities. This one was a little weird for me, because in order to, if we're going to use semantic search or some kind of vector search on medical data, at first it has to be vectorized, which implies the inclusion of an AI model. Now, this is a spot where some of my research failed me. What AI models are out there that are able to embed an EEG or an EYG or any of these other things, the electrical signals on your skin, how many beats per minute your heart is going, whether your eyes flicker, whether you're having myoclonic jerks. These are all things that require a little bit more attention to the minute details, and being able to vectorize those would be a great way for large medical experiments to be able to sort through data and identify things that might actually impact and infer the things that are going on inside of your body. And of course, there's always traces and logs. I've talked about those. Traditionally used for troubleshooting software, of course. This can be adapted very easily to monitor the flow of events in your system. Food goes in your stomach, insulin gets released in your blood, which is also a biomarker for many kinds of conditions within your body. And anything that triggers a biological response, we can trace, blood samples, et cetera. And of course, OpenSearch dashboards is a great spot to make a dashboard for those kinds of things. And what I imagine is a real-time dashboard. If we eventually, when we get to the point where biosensors are even smaller, easier to implement, and like I said in my abstract, I said, I'm not advocating for putting chips in your brains. But as these things get smaller and smaller, I sure wouldn't mind having a readout of all of the stuff that's going on in my body. And then what might happen is I'll notice a correlation. And these correlations are what help us define, by nature of them being corollary, what might be breaking in our bodies. I didn't set a timer. Oh well. And so along with anomaly detection, or vector databases implying the use of an AI model, let's not forget Gen AI. There's a spot there for that too. How many other cases are like this, and you get some voice prompt back, or plain text response back offering some suggestions. And like I said, I'm not a doctor. I don't recommend replacing a doctor with these kinds of things, but these are perfectly valid places where OpenSearch can be used to supplement diagnosis and inferring your body's internal state in the form of bioobservability. So I think I've beat the point home there for long enough. What else is there? I thought of one area where there's no way to put a biosensor. There are some things that we just cannot infer the internal state. And so let's talk about mental health for a second. I don't know if any of you have ever had a mental health evaluation, but it's a lot of questions. I mean, I wouldn't know, but it's a lot of questions. And they can't put a chip in your head that will determine your mood. They can't put a chip in your head and determine, oh gosh, well, I've been anxious, my anxiety rating is 7 out of 10 over the last 2 weeks. How much stress have I been feeling at work? These are things that we don't have chips for that yet, and we don't have the technology. So usually what that means is the patient or the user supplementing that data by answering forms and answering survey-like questions, things like that. So that's something that I think we're going to need to work on before we can start monitoring mental health or even implementing bioobservability on this kind of thing. I'm not sure if it'll ever happen. But I would love to hear your thoughts on that when I'm done speaking here. I'll give you guys a few minutes to ask me questions. One of the things I wanted to talk about was the native storage of samples. You know, the EEG that I had done, the week-long inpatient EEG, you know, those are just audio recordings pretty much. We've already performed multimodal search on audio, video, and images. So the native storage of samples is not something that I think we have a data type for yet, but it's storable in OpenSearch. There's just not a lot of application of that. There's not a lot of people doing this specifically for medical information, and I'm sure there's lots of legal blockers for that kind of thing. But that might be if you wanted to, you know, do research on the various EEGs of the different seizure types or the different parts of your brain that might be misfiring. Having those stored in OpenSearch would be a very valuable part of bioobservability for that particular symptom. So same problem here, embedding and vectorizing samples. I'm not privy to any specific AI models that people have put out that are open source, saying, hey, use this to vectorize your EEG, or you know, here's your latest protein count in your urine. You know, some of those are just statistics. We can put them in as numbers, but some of them do require the storage of the actual sample data, or it can lead to much more discovery about the internal state of your body. And so those are things that I think in the future will need some work before we see a full-on use of OpenSearch for bioobservability. And of course, AI assistance. Same problem there. So bioobservability. Observability can be applied to the human body, yes. It doesn't have to be the human body, though. Bioobservability refers to a lot of other activities that actually are in use today. We can monitor pollution in our air, you know, satellites taking images or using some kind of whatever process it is that they use to determine how polluted the air is. So that's a spot that they could be, that observability is used. It's used on our environment. What about pharmaceuticals? Well, we can discover new drugs, medicines. And what else? Has anyone heard of the term pharmacovigilance? So this is when medicines are given to people and you want to take perform long-term observability on them to make sure that there's no ill effects from that medicine, or that it's not long-term harmful to a person, or that you know, it's an appropriate treatment for whatever you're feeling. This is quite doable as well through the same process, by ingesting data, looking for correlations and anomalies, and performing that over a long period of time. Agriculture. So I remember when the Arduino builder kits came out, you could buy these little humidity sensors. I'm sure they've been out for a long time, but these open source humidity sensors, you could place those over your garden, and then all of a sudden you've got bioobservability on how wet your soil is or how fertile your soil is. Oh yeah, I mentioned environmental protection. Sorry, I spat that out of order. But yes, there's lots of things that we can observe about our environment, tree cover, pollution, and interestingly enough, at a previous OpenSearchCon, I had a really interesting conversation. This just popped into my head, but satellites sometimes take pictures of the ocean as they're floating around. And this customer was trying to vectorize the images so as to help identify people lost at sea. Now, while not strictly bioobservability, you're technically saving a human, so I will allow it out of grace. But vectorizing the pictures of the ocean and looking for minute changes and anomalies in how they normally look, you might be able to save someone's life. Yes, water quality, sensors that tell us about pollutants that are in the water. All of these things are things that the data itself, metrics, stats, numbers, logs, traces, keywords, etc. These are beautiful things for OpenSearch to ingest and compute on. Ooh. Enjoy my bullet points one more time here. So what's out there? There's I don't want to name names or anything because there's too many to count, but there's a lot of sensors. I'd like to point out that for a one-time donation to me of $33,000 via Venmo, we can get a 16-sensor headset that will monitor your orientation in space and time, the electrical activities on your skin, heart monitor, which direction your eyes are facing. Did you guys know that there are certain disorders that you can identify based on which direction your eyes are looking as you're thinking about a certain subject? Or if you're walking and suddenly your muscles are not as strong as they should be, some people's muscles go limp that's a form of epilepsy. Just those 16 sensors can actually reveal quite a bit about what's going on in your body. And I'll just repeat that, donation via Venmo, and I will come back next year with a fully working example. So, gosh, I'm coming up on time, I think. So I wanted to wrap this up, and I wish I had a working example for you. I really wanted to come here today with some sample code. Hey, here's a little piece of equipment stuffing data into OpenSearch. But what I thought I would do instead is to make a plea to researchers and builders of these kinds of things. For one thing, you get an open source advantage. If you're doing research with open source tools, it makes it that much easier to make your research open, repeatable, and shareable. There are also some bioobservability specific benefits of this. Like I mentioned, being able to go over time series data, query large amounts of records, which our bodies are bound to create. And it's also a cost-effective solution without any vendor lock-in as well. So I encourage, even if you're not interested in medical research or observing your own body, there's a case to be made for exploring OpenSearch as a means of bioobservability, and you never know. Something might interest you that you want to start recording about yourself. And I know ever since my close call with some semi-permanent epileptic seizures that it has spawned my interest in this kind of thing, and it's actually very interesting now because I love having my step counter, and I've got a little heartbeat sensor that I put my thumb on, and it can record and query all of these very interesting statistics. There's also a growing body of bioobservability tools that could be contributed to by taking on OpenSearch as a tool for medical research. And you also get to join the OpenSearch community. So we really can, with OpenSearch and the right kind of observability, with bioobservability, we can create more powerful tools and more accessible tools for biological research. Do I have any more slides? Nope, that's it. I wanted to open up the floor. If anyone has any comments or stories they'd like to share, like what, are there any use cases that I might have stepped over that interest anyone? Is there anyone who's interested in the subject, interested in bioobservability? Yeah, sure. I'm sorry? My own data, not a cluster, but I run a very limited instance of OpenSearch on my laptop that I just, it's not exactly real time. The question is, do I have my own cluster that I store my own bioobservability data on? I have an instance on my laptop that I import into every once in a while. And it's interesting to me. I like seeing the graphs get created and all that stuff, and it makes me wonder, you know, how much could I contribute to medical research one of these days. And I've given it some thought. Yeah, it's an interesting subject, and I think I tend to just be for small scale kinds of things. Like I would only want to record myself. I didn't even want to touch the the legal matters of like storing other people's bioobservability data. I'm sure that's a nightmare. But say if you're a family and you want to keep tabs on your kids, you just keep a little local cluster of your health metrics. Triglycerides in your fat. It's all of these markers that indicate health. I hope that was interesting for everyone. I think I'm done.